Dear friends, in previous class we already discussed about the Dirichlet inverse of a function. Now we prove that f inverse of 1 equals 1 by f of 1 and f inverse of n equals minus 1 by f of 1 into sigma d divided n d strictly less than f of n by d into f of n by d into f of d when n greater than 1. So this can be proved. First you consider given f4, then we shall prove that the equation f star f inverse of n equals I of n. We have to prove the equation f star f inverse of n equals I of n has a unique solution for the function value f inverse n. When n equals 1, what happens? N equals 1, the result is immediate. Why? What about consider this equation f star f inverse of n equals means when n equals 1, it is f star f inverse of 1 equals I of 1. It is I of 1. What is I of n? I of n is greatest integer 1 by n. So I of 1 equals 1 itself. Come to the left side. By the definition, it is sigma d divides n f of 1 into f inverse of or f of sigma d divides n f of 1 into that one, or it can be rewritten as by the definition f star f inverse of 1 equals sigma over ab equals 1 f of a into f inverse of b, that equals 1. I of 1 equals 1. Sigma over ab equals 1 f of a into f inverse b equals 1 means when ab equals 1, that implies a equals 1 and b equals 1. So this may be rewritten as f of 1 into f inverse 1 equals 1. That means f inverse 1 equals 1 by f of 1. So it is proved. So when n equals 1, f inverse 1 is 1 by f of 1. Now the second part, f inverse n equals minus 1 by f of 1 into sigma d divides n d less than n f of n by d f inverse d into f inverse d. That can be proved by using induction hypothesis. The result is true for n equals 1. Now we suppose that the result is true for every function value f inverse k have been uniquely determined for all k less than n. Then we have to solve the equation f inverse of or f star of f inverse of n equals I of n. What is f star f inverse of n? That is, we have to solve sigma d divides n. Sigma d divides n, it is f of n by d into f inverse d equals what is I of n? When n greater than 1. When n greater than 1, this I of n equals 0 by the definition of this I of n. So sigma over d divides n, f of n by d f inverse d equals 0. What is sigma over d divides n? This can be rewritten as sigma over d equals n and d less than n of f of n by d f inverse d equals 0. That means when d equals n, what about this one? That can be rewritten as it is f of 1 into f inverse of n when d equals n, the first term, plus come to the second term and the remaining term sigma over d less than n as well as d divides n f of n by d into f inverse d equals 0. That means f inverse f of 1 into f inverse n plus sigma d divides n, that one. So what about f inverse n? From here f inverse n equals minus 1 by f of 1 into sigma over d divides n d less than n f of n by d into f inverse d. This is what we recurse here. So this formula is important. F inverse 1 equals 1 by f of 1, that is Dirichlet inverse, and F inverse n equals minus 1 by f of 1 into sigma over d divides n, d less than n, f of n by d into F inverse d. Yes. Now, the set of all arithmetic function with a f of 1, the set of all arithmetic function with f of 1 differs from 0 always forms an abelian group with respect to the binary operation star. We already proved that the Dirichlet product star is commutative as well as it is associative. Then here f star g of 1 equals f of 1 into g of 1 and so on. Now we define the unit function. What is a unit function? No definition. There is a unit function u of n. So u of n equals 1 for all n. So this is the unit function. Unit function is also an arithmetic function which is defined as u of n equals 1 for all n. But we also know that sigma over d divides n mu of d. Sigma over d divides n mu of d equals greatest integer 1 by n. We already proved this result. For Mobius function, mu sigma over d divides n mu of d equals 1 by n. But actually what is greatest integer 1 by n? Greatest integer 1 by n equals I of n. This function is also defined here. I of n. So means sigma over d divides n mu of d equals I of n. Means sigma, that is yes, I of n equals, this I of n can be rewritten as I of n equals sigma over d divides n mu of d, that is mu of d into, not simply I of n equals sigma over d divides n mu of d. But we have, what is mu star u? Thus mu star u equals I. From here, mu star u equals I. Why? Because what is mu star u of n? Mu star u of n equals sigma over d divides n mu of d into u of n by d. What is u of n? U of n equals 1 for all n. So d runs through the divisors of n, hence this d also runs through the divisors of n by d. So it is sigma d divides n mu of d, sigma d divides n mu of d equals I of n. So finally mu star u equals I. Mu star u equals I, since star is commutative, again u star mu is also I. That means u and mu are act as the Dirichlet inverse of each other. U star mu equals I. How we define the Dirichlet inverse? If f is an arithmetic function, then f star f inverse equals I. Then f inverse is said to be the Dirichlet inverse of f. Then in the light of that argument, u star mu equals I means u be the Dirichlet inverse of mu and vice versa. That is u inverse equals mu and mu inverse equals u. So this obtained from the unit, the function, the arithmetic function u of n equals 1 for all n. Then u of n equals 1 is said to be, this function is said to be the unit function. So this result is obtained from the definition of unit function. Agreed. Now let us discuss the Mobius inversion formula. That's an important result. Mobius inversion formula means, Mobius inversion formula means Mobius inversion formula. The function f of n equals the equation f of n equals sigma d divides n g of d. Sigma d divides n g of d implies g of n equals sigma d divides n f of d into mu of n by d. F of d into mu of n by d. Reversely, if g of n equals the equation g of n equals sigma d divides n f of d into mu of n by d, then f of n equals sigma over d divides n mu of sigma d divides n g of d. F of n equals sigma over d divides n g of d, that implies g of n equals sigma over d divides n f of d into mu of n by d. Then reverse inversion is also called. Then the Mobius inversion formula states that the equation f of n equals sigma over d divides n g of d if and only if g of n equals sigma d divides n f of d into mu of n by d. So come to the proof. Let the necessary argument, let f of n equals sigma over d divides n g of d. F of n equals sigma d divides n g of d. Then sigma d divides n g of d can be rewritten as sigma d divides n g of d into u of n by the definition of unit function. Since d runs through all divisors of n, hence d runs through the divisors of n by d. So sigma over d divides n g of d can be rewritten as sigma over d divides n g of d into u of n by d. That means from here f equals g star u. F equals g star u. Now, what about f star mu? F star mu equals it is g star u star mu. Since star is associative, it is g star u star mu. But by the previous argument, we have g star. What is u star mu? U and mu are the Dirichlet inverse of each other. Means u inverse equals mu as well as mu inverse is u. So u star mu is always identity. We also prove that when I is an identity function, f star I equals f, so g star I equals g. So that means g of n equals sigma over d divides n f of d into mu of n by d. From here f star mu equals g means g of n equals f star mu of n. F star mu of n by definition it is sigma over d divides n f of d into mu of n by d. So necessary part is finished. Now come to the reverse inversion. What is the reverse inversion? For a sufficient argument, just we suppose that g of n equals come to the right side. G of n equals sigma over d divides n f of d into mu of n by d. So from here it is given g equals f star mu. G equals f star mu. So what about g star u? G star u equals this f star mu star u. That means since star is associative, it is f star mu star u equals f star. What is mu star u? Since mu and u are Dirichlet inverse of each other, it is f star I. Again f star I equals f. So that means what is f of n? F of n equals g star u of n. F of n equals g star u of n. G star u of n. G star u of n means it is sigma d divides n g of d into u of n by d. But u of n by d is 1 by the definition of unit function. So it is sigma d divides n g of d. Thus f of n equals sigma over d divides n g of d. So the reverse inversion is also made. So this is the Mobius inversion formula. Enough. So by using these identities, we have what is n? We already proved that n equals sigma over d divides n phi of d. Sigma over d divides n phi of d equals n. But also we also define a function n of n equals n for all n. So combines from these two, what do you get? We have n of n equals sigma over d divides n phi of d. Sigma d divides n phi of. What is Mobius inversion formula? Mobius inversion formula states that if f of n equals sigma over d divides n g of d, then this implies and is implied by g of n equals sigma over d divides n f of d into mu of n by d. This is Mobius inversion formula. using Mobius inversion formula. When f of n equals sigma d divides n g of d, what is g of n? G of n equals sigma d divides n f of d into mu of d. So by using this argument, from we have n of n instead of f, here it is n, instead of g, here it is phi. So it is by Mobius inversion formula, phi of n equals sigma d divides n, it is n of d into mu of n by d, n of d into mu of n by d. That equals sigma over d divides n. What is n of n? N of n equals n. So what is n of d? It is d. So d into mu of n by d. D into mu of n by d. Means phi equals phi of n. So this is another result. Phi of n equals sigma over d divides n, d into mu of n by d. Agree? Again, from here come to this argument. What is phi there? Phi equals n star mu. Okay, phi equals n star mu. Phi of n equals sigma over d divides n of d into mu of n by d. That means phi equals n star mu. Since star is commutative, this n star mu means mu star n. Agree? N star mu means mu star n. That means phi equals mu star n, means phi of n equals sigma over d divides n mu of d into n of n by d. N of n by d. What is n of n by d? What is n of n? That is n. So that means mu of n equals sigma over d divides n mu of d into n by d. So this is another result. Phi of n equals sigma over d divides n mu of d into n by d. Okay, right. Now we define another arithmetic function which is known as man-dot function. M-A-N-G-O L-D-O-T, man-dot function. So the man-dot function is usually denoted by this way. It is called as lambda n. So the function is defined as, for any integer n greater than or equals 1, n is an integer means n greater than or equals 1. For any integer n greater than or equals 1, then we define this lambda n is the man-dot function. Lambda n equals, it is log p, where p is any prime, log p if n equals p power m, where p is a prime number, and for some integer m greater than or equals 1. For some prime p and some integer m greater than or equals 1, 0 otherwise. So the man-dot function is defined as this way. For any integer n greater than or equals 1, then lambda n is defined as, it is log p when n is expressed as the power of product of primes, and otherwise its value should be 0. So what about lambda 1? Lambda 1, so it is log 1, so lambda 1 log 1 equals 0. What is lambda 2? Lambda 2 means 2. 2 can be rewritten as, what is 2? 2 equals 2 raised to 1. So it is p power m. So it is log p means log 2. By definition, it is log 2. What about lambda 3? Lambda 3 means again 3 raised to 1. So it is as of the form. So its result is log 3. What is lambda 4? Lambda 4 means, it is what is 4? For n is 4, can be expressed as 2 square, product of power of primes. So it is p power m. So lambda 4 is again log 2. What is lambda 5? Lambda 5 is log 5. What is lambda 6? Lambda 6 means 2 into 3. Cannot be expressed as the power of product of primes. So it is the next form. So lambda of 6 equals 0. Then you can find out the values of lambda 7, 8, 9, 10, etc. and so on. Okay. So this is the definition of man-dot function. So man-dot function is defined as, for any integer n greater than or equals 1, lambda n equals log p when n is p power m for some prime p and some integer m greater than or equals 1, 0 otherwise. Okay, now we prove another result. That's in next class. So, thank you.